Once density is set, the real formula calculation is only starting. The next thing you need to establish is how much total forming volume the system roughly needs. Only when that direction is clear can you move on to water level, blowing rate, and isocyanate requirement. Put simply, total forming volume means this: how much final volume the raw material needs to expand it into in order to reach the target density range. You know the target density, and you know approximate mass of the raw materials. The extra volume that still needs to be created by gas is next problem the formula has to solve. In the typical flexible PU form system, that forming volume mainly comes from two sources. One part comes from the carbon dioxide generated by the reaction between water and isocyanate. The other parts comes from the evaporation of physical blowing agents. So when you continue the formula work, the first thing you really need to establish is not the number of one single raw material, but the total forming volume required by the whole system. A water-only system is often used as the first step to build this framework. The reason is simple. It is not because a water-only system is naturally the best route, but because it works well as a starting point. When water reacts with isocyanate, carbon dioxide is generated. That relationship is relatively clear. When water changes, carbon dioxide output changes. When carbon dioxide output changes, forming volume changes. And when forming volume changes, the density direction changes with it. This gives the formula its first calculation path that can be followed step by step. So the main value of water-only system is that it gives you a clear calculation starting point. Using it to build the total forming volume framework is much more reliable than guessing the water level from experience at the beginning. But problems also appear very quickly. If water alone carries the forming task, it is often difficult to balance density, softness, tear strength, and overall hand feel at the same time. The foam may rise and the target density may be reached, but the final property profile is not always ideal. That is because the reaction between water and isocyanate does not only generate carbon dioxide, it also forms and rear groups and changes the structure of the system. Once the water level goes up, the effect usually becomes more obvious. This is also why a common misunderstanding appears so easily on production floor. Treating water only as a tool for lowering density, especially in low-cost systems, once the target is lower density, the first reaction is often to raise the water level. But increasing water does not only change volume, it also changes the exotherm structure and the later processing window at the same time. If those effects are not judged together, the formula can easily drift in the wrong direction. So a water-only system is suitable for establishing total forming volume first, but is not suitable to be treated directly as the final route. The real question that comes next is this: on that basis, which part of the forming task should still be carried by water, and which part should be handed over to physical blowing agents? In other words, the next discussion is no longer just about whether the volume is enough. It's about how the whole forming task should be divided. In the next episode, we will move on to the next question. Are water and physical blowing agents simply replacing each other, or are they jointly defining the whole formula route? If you want more practical ways to handle common formulation issues in continuous flexible PU foam production, comment, adjust below. We will share the document 8 Practical Adjustment Approaches for Flexible PU Foam in Continuous Foaming Production. You can also download it directly from the link in the video description.